Okay. So when we are talking about our projectile motions, right? We've got two types of projectile motions. You'll be dealing with horizontal projectile and you will be dealing with vertical projectiles. Now, when we are talking about our horizontal projectile, so a horizontal projectile is where the object is going to be directly falling on the ground, like they've shown you in an example, right? You are standing at a cliff and you kick the ball, and the ball ends up, directly falling onto the ground. That is going to be a horizontal projectile. Or you have, let's say, a cannon over here, right? And that cannon shoots a ball and the ball falls directly onto the ground. That is going to be a horizontal motion. So the first thing, whenever you're like dealing with these questions, the first thing you have to deal with is whether it's a horizontal projectile or a vertical projectile, because for both of them the rules are pretty different. So you need to go ahead and identify what you're dealing with. This is
Okay.
what you will, yeah, so this is a horizontal projectile. In a vertical projectile, the object will first go
Okay, right. So
up
you like throw it
and then it will
upward.
come back down. So for example, you're exactly in a horizontal projectile, it's not going to go up, it's just directly going to go fall on the ground. In a vertical projectile, you are throwing the ball up or you're throwing something up and then it is coming back down. So an example would be, you're playing tennis, you're playing badminton, you're playing volleyball. You're just, if something is going up and then it is coming back down, that is going to be a vertical projectile. And if it's directly going on the ground, then that's a horizontal projectile. So the
Oh,
rules for both of them, yeah, the rules for both of them are different. So we will start with the horizontal projectile first. Okay, a couple of going over it. So this particular concept is related to vectors. Okay, when you are talking about a ball that has been kicked and it's falling on the cliff, now this particular ball is going to have a speed. That speed is going to be the resultant speed,
okay, yeah.
right? Now, of this resultant speed, there are going to be two components. You're going to have a vertical component and you're going to have a horizontal component. Because see, when you are kicking the ball, you are applying a horizontal force. Once the ball is off the cliff, now gravity is included in it, right? You
Yeah.
kick the ball straight. Gravity is pulling the ball down. The ball is going to end up falling the resultant path. So
Yeah.
that is, yeah. So the same thing is going to follow for velocity. You have your resultant velocity. You have your, so we write down V, and then we write down H, and we can write down V and we write down V. So whenever you see me write down VH, that means it's the velocity and the horizontal component of the velocity. If I write down VV, that means we're dealing with the vertical component of the velocity. If okay, so that's like the first, just the terminologies that you're going to be dealing with in your questions, right? So VH is the horizontal
Okay, right.
component, yeah. VV is the vertical component. Now, when we talk about velocity, you have final velocity and you have initial velocity. So initial velocity is often written as UH, so the horizontal component of the initial velocity, and UV would be the vertical component of the initial
Initial
velocity.
velocity. Okay,
Yeah,
right.
so this is for final and this is for the initial. So VH is going to be the horizontal initial final, VV would be horizontal, sorry, vertical final, UH would be
Is it,
horizontal initial.
would
Yeah,
you call would you call it initial horizontal only or initial horizontal speed?
initial horizontal velocity.
Oh yeah, sorry, velocity. I mean, okay,
Yeah,
right.
velocity. Yeah, exactly. So that is what the terminologies are. Now, there are two particular situations. Okay. One situation is that when they're going to go ahead and directly just give you the resultant velocity. Okay. So if
Oh,
they give you a resultant velocity, then of course it is going to be up to you to figure out the vertical component and to figure out the horizontal component. Sometimes they will give you the horizontal
right.
component and sometimes they will give you the vertical component. They'll usually mention pretty clearly what you are going to be dealing with. Now,
Okay.
Now that let's go ahead and start discussing what rules are going to be applicable over here. Okay, first of all, horizontal component and vertical component are always going to be, independent. Okay. What do I mean by that? Horizontal does not have an effect on the vertical. Vertical is doing its own thing, horizontal is doing its own thing, and their combined effect gives you the resultant. So if the horizontal is changing, that does not mean necessarily vertical will change, or vertical is changing, that does not necessarily mean that, horizontal will change. So
Okay.
that's the first thing. Second thing, okay, so when we are talking about initial vertical velocity, so this is just for horizontal, right? Horizontal projectile, this kind of projectile. The rules for the other one, the vertical one, we're throwing it up, those are different. So in a horizontal projectile, if you look at the vertical velocity, the initial velocity is always zero. So you're always going to be starting with an initial velocity of zero. Initial velocity of the vertical component is always going to be zero.
Okay, right.
While the initial, so while the horizontal component is what is going to be either given in the question or what they will ask you to find out. So for example, over here they say a stone is kicked horizontally off a cliff with a velocity of 8.2 meters per second.
Oh,
So this 8.2 is the horizontal component,
right. Yeah.
because the vertical component is automatically zero. That's the first rule of this. Second rule, there is no horizontal acceleration, right? When we
Right.
are talking about the horizontal component, there is going to be no acceleration. The horizontal speed is going to remain the same throughout. Horizontal speed is not going to change. When we talk
Yeah.
about the acceleration of the vertical component, so the acceleration for the vertical component is going to be 9.81 meters per second square, because the acceleration is due to gravity. Since the acceleration is happening
Right.
because of gravity, so it's a fixed value. Acceleration is always going to be 9.81 meters per second square. Now,
Right.
since the horizontal component has no acceleration, since it is constant speed, so whenever you're dealing with horizontal acceleration, you can go ahead, horizontal velocity, you can go ahead and simply use the formula speed is equals to distance upon time. So like I'm just telling you like a shortcut, right? You see the horizontal component, you know that there is no acceleration involved. So what are you going to do? You're going to go ahead and you're going to say that, I don't need to look at any other equation. I'm just going to use speed is equals to distance upon time.
But
Now,
isn't
when,
it also
yeah.
impacted by, like, since the resultant
Mhm.
velocity is different, so how, like, won't it be incorrect, whatever you get from this? If
No,
I,
because the answer you'll get from this is going to be the answer only for the horizontal part, right? For example, let's say you want to find
oh,
out the time. Yeah, you want to find out the time. So the time, whether you're using resultant, vertical or horizontal, you should be getting the same time, right? Because the time overall for the ball to fall is going to be the same. The distance, what distance is it going to go to? It doesn't matter which velocity you use, you should be getting the same distance, because that is not going to change. The time is not going to change. So whether you're using horizontal or vertical, it's not really going to affect it. The only reason I mentioned the resultant part is because if they give you the resultant, then you first need to find out the vectors. You first need to find the vertical and the horizontal, so you can use the formulas, because the formulas are not for resultant velocity. The formulas are going to be for, if you're talking about, okay, if you're talking about your kinematic equations, so in kinematic equations, when you talk about resultant velocity, so you will have to take resultant acceleration, right? That is going to be a whole lot of calculations that are going to make everything much complicated. It's just easier to go ahead and divide it into vertical velocity and horizontal velocity, and then apply your equation, because you know for sure that vertical acceleration is 9.81 meters per second square. So that just makes things a bit easier. That's why.
Oh, okay.
So in horizontal, yeah, so horizontal component, we use speed is equals to distance upon time. If we want to use vertical component, we are going to go ahead and then always use our kinematic equation. So
Oh,
yeah, so this particular question, right, let's say that they go ahead and they ask you how much time is the stone in flight, like how much time has, the stone, how much time did the stone took to fall down. So vertical distance, as you can see, is given to us 60
yeah,
meters.
right.
So what you can go ahead is you can use one of your kinematic equations over here. Now remember this, for the vertical velocity, we will always use the vertical distance, and for the horizontal velocity, we always use the horizontal distance. So we can go ahead and simply use the equation S is equals to ut plus half at square.
Yeah.
We have, yeah, we have everything over here to find the time. The distance is 60. The u, we always know that in the vertical
8.2,
component,
right?
yeah, it's 0.
Yeah,
We know
it's
the yeah, we know the acceleration is
42.
9
That's
point.
what I'm about. Never mind.
Yeah, exactly. So you can go ahead and you can find out whatever the time is. And then the second part of the question is how far does it get away from the cliff by the time it lands? So they're asking you to find the distance. So this is horizontal distance, right? For
Yeah.
the horizontal distance, you need to use horizontal velocity. The formula is simple. Speed is equals to distance upon time. Time you have calculated already. The speed is given to you 8.2, so you can go ahead and find out what the distance is. So these are the rules for horizontal projectile. Initial vertical speed is always 0. Initial horizontal speed is going to be whatever is given to you. There is no horizontal acceleration. The vertical acceleration is going to be 9.81 meters per second. For horizontal component, we can simply use speed is equals to distance upon time. For the vertical component, we need to use kinematic equations. And then using these rules, we can go ahead and we can pretty much solve any question that they give us. All clear on this part?
Yeah.
Okay, and this will get a bit more clear. When we start doing past paper questions and you start applying the rules, it's going to become much more clearer.
Yeah. Yeah. Okay. I think I got it. Thank you.
Yeah. Okay, now let's talk about vertical throws, right? So a vertical throw or a vertical projectile is like when you're throwing the ball up.
Yeah.
Now, in this particular situation, rules are a bit different. How are rules a bit different? First of all, your okay.
Hello.
So
I'm
when
sorry.
yeah,
I
when
could.
you
Oh, no, when you cut off.
yeah,
Oh,
okay.
sorry.
So
Never
the
mind.
yeah, the initial vertical velocity is not going to be 0. So over there, the initial vertical velocity was 0. Over here, the initial vertical velocity is going to be something else, whatever numerical value is going to be given to you. So once again, this is your resultant velocity, and you're going to go ahead and find out the vertical component, and you have to go ahead and find out whatever is the horizontal component. So whatever is the vertical component that you end up getting, that is going to be the initial vertical speed. When we reach the very top, when we reach this particular point, at this point, the vertical speed is going to be 0, right?
Yeah.
Because you must remember, whenever you throw like a ball straight up, at the top the speed becomes 0. So the same thing is over here. At the very top, at the very maximum height, the vertical velocity is going to be 0, not the horizontal. The horizontal velocity, like I told you, it does not change. The horizontal velocity is going to remain constant throughout. That is why for horizontal velocity, we can go ahead and use our speed is equals to distance upon time. Vertical velocity is going to be 0 at the top. Now, the acceleration, when you are going to be throwing the ball upwards, the acceleration is going to be negative 9.81. And when the ball is going to be coming down, it's going to be plus 9.81.
Yeah.
Now, when we are solving questions related to this particular topic, we are going to be doing them we are going to be doing them in such a way that we are going to be dividing our motion into two. So I'm solving this, right? What I'm going to do is that I'm going to, let's say they want me to find out the time for the total journey, right? They're saying how much time did it take for the ball to go from here all the way till here. I'm going to start
Yeah.
with my vertical component. Now, there's one possibility where they will give you the vertical component, which makes things easier for you. The other possibility is that they tell you the resultant. For example, they say that the person threw the ball at the speed of 8.2 meters per second at an angle of 60 degrees, for example, right? If that is the situation, then you will, of course, have to go ahead and find out the value. You will have to apply your either cos, tan, or sine, or apply, one of the trigonometric formulas to find out what the vertical component is. Once you have found out what your vertical component is, you can go ahead and apply your kinematic equation. So the formula you can go ahead and apply is simply v is equals to u plus at.
Right. Okay.
Okay. The final velocity at the very top, we know that our final velocity is going to be zero. The initial velocity is going to be, whatever calculation you have done, whatever value is given to you over here, that would be, be your initial velocity. The acceleration would be minus 9.81, and then you would end up finding your time. Now, the time you have found is only for like half of the journey, right? So you would have to multiply the time you have found by 2, so you can find out the time taken for the total journey. So that is what we do over here, because we don't know what is the speed of the ball when it lands with the other person. So we divide the journey into two. We say, okay, from the start to the very top, and then from the top to the end. So that is how we solve it. If you want to find out the vertical distance, like how far the ball went, you could once again find out your time. And after finding out your time, you could use any of your formulas. You could use v square is equals to u square plus 2as, right?
Okay,
The
right.
Yeah, v square you can take it as 0, u
Zero.
square you can go ahead and whatever you have
Yeah.
in your question, acceleration you have, and you can find out what the vertical distance is. If you want to find out the horizontal distance, once again, you can just use speed is equals to distance upon time. You need to find out what is the horizontal component of the speed, which you can find out by using, your trigonometric ratios. And then the time you have already calculated, so you can go ahead and find out.
Okay, we can find the speed by trigonometric ratios. I thought that. Okay.
If yeah, if the resultant is given to you, then you will have to use trigonometric ratios, right? If they've given you, I'm throwing a ball at the speed of 10 at an angle of 60 degrees, so then you have to use trigonometric
Okay.
ratios
Right.
to,
Right.
get the
Oh.
vertical and the horizontal component.
Oh.
Yeah,
Okay.
in
Yeah.
those
Yeah. Okay. Then.
situations. Yeah. If they directly give you the value, then of course you don't have to worry about it.
Okay.
Okay. So those are the rules for vertical projectile. Is there any confusion in this?
No.
Okay, so let me just open up a few questions. 1 second, and let's go over this topic. Okay, let's go ahead and take a look at this particular question. So, what the question actually states is a ball is thrown vertically down towards the ground with an initial velocity of 4.23 meters per second. The ball falls for a time of 1.51 seconds before hitting the ground. Show that the downwards velocity of the ball when it hits the ground is 19.0 meters per second. So the information given to you is the initial velocity and you have the time. So this is pretty simple. Actually, it's not even related to projectile motion. You need to decide from the four kinematic equations which one is applicable over here that will allow you to figure out the final velocity of the ball.
Okay, so we know the initial velocity, the time, and the acceleration. So
Yeah,
it will
good.
be uh wait, ut plus half at square equals, but we don't know the distance. So oh, it's v.
Exactly.
Oh yeah, v equals ut plus. I mean a equal. Wait, sorry. Oh yeah, at plus u equals v.
Yeah, good. Good job. That one's perfect. And if you go ahead and you apply v is
Oh,
equals to v plus at, so your initial velocity is 4.23. Your final velocity, since it's going downwards, so it's going to be positive 9.81, and this is going to be 1.51. So just quickly go ahead and put it and see if you're getting the answer of 19.
yeah, I'll just check on a calculator. Yeah, let me just check. Oh, sorry, 1 second. Oop, I opened the wrong calculator.
No, no, it's no worries. Just take your time.
Okay. Plus, it's into 1.51, right? The time? Okay, yeah, it's 1.5. Yeah, it's 19.04. So it's like
Yeah,
rounded to
yeah,
the significant figures.
yeah.
Yeah.
Good job. Fine. Now, the second part is calculate to three significant figures the distance ball falls from the ground. So now you have all your data available. Once again, you need to decide which kinematic equation is available, and then you can calculate what the distance is.
Oh, okay. I just have a question. For this, we don't use this we have to calculate with using the vertical velocity, right? Because this is the
Yeah, yeah. This is simple vertical motion. It's not a projectile, right? In a projectile, you're dealing with both. You're dealing with a horizontal and a vertical. That's when you know throwing the ball both vertically and horizontally at the same time. This is just you dropping the ball straight down. This is just plain vertical motion. That's it.
right. Okay, okay, right. So
This is
uh,
not a projectile motion. This is just plain.
uh,
You're throwing the ball straight down. That's it.
we could just use ut plus half 80 square equals,
Yeah,
right,
yeah,
the distance.
yeah.
So
You
the
could
initial,
use that. There's another one that you can use. That's v square is equals to u square plus 2as. So
yeah,
both
plus
two have, yeah, two formulas are available. Whichever one you decide to go with.
oh, okay, right. Should I like find the answer?
Yeah, just go ahead and let me know. And do be careful about the significant figures because they deduct marks for that.
Yes. Wait, also for this, because it's vertical, we use initial velocity as zero, right?
Mm-mm.
Oh no.
Initial velocity is 4.23. Remember, in vertical projectile, the initial velocity is going to be whatever is given to you. The velocity at the very top, that is where you're going to have zero. And since this is not even a projectile, in a projectile you are throwing the ball far away from you. This is you dropping it straight towards the ball, like straight towards the ground. You are not throwing the ball anywhere. You're not putting any horizontal force. That's like I'm holding the ball and I simply let go and it falls
Okay.
towards the ground. Yeah, so there is no
Oh.
projectile involved.
I thought only when you throw it like up, can you have like an initial velocity? Otherwise, I thought that it's always
No,
equal
no.
to
It's
zero all the
it's go
time.
it's no, no. Initial velocity is going to be it's given to you. It's written in the question with an initial velocity. So they've actually mentioned it for you.
Yeah, okay, that makes sense.
When I'm throwing the ball straight down, right, there needs to be some initial velocity because the ball needs to fall down. I'm not applying any horizontal force because I'm throwing it straight down. So there needs to be some sort of vertical force to, make the ball go down.
Okay, right. Okay, so it's coming to wait, this is the three significant figures. Okay.
Yeah.
It's 17.57 if I round it to four significant, so it's 17.6 meters.
Yeah. Good job. That's completely correct. Okay.
Yeah.
Now, this is another question that you are going to be dealing with. This is again, this is not related to projectile motion. You're simply dropping the ball down. Okay, so a ball is thrown vertically down towards the ground and rebounds as illustrated. As the ball passes A, it has a speed of 8.4 meters per second. The height of A is 5 meters above the ground. The ball hits the ground and rebounds to B. Calculate the speed of the ball as it hits the ground. This is once again, this is a simple question.
As it comes back up, right? Calculate the speed
Yeah,
as the ball hits the
as
ground.
it hits the ground, as it is hitting the ground, not when it's coming back up, when it's hitting the ground.
Okay, so we know the acceleration, we know the distance, and we know the final. I mean, we know the initial velocity. So we can
Yeah.
use anything, right? Basically, I mean,
Yeah.
we can use
Hmm.
but the easiest one, I guess, would be v equals to u plus at. Oh no, we don't know the time. My bad, my bad. Sorry. 2as equals to v square minus u square, or s
Yeah.
equals ut
Yeah.
plus at, right?
You
80
could
square.
definitely do, yeah, you could do v square is equals to u square plus 2as. Initial velocity is given to you. The acceleration is going to be plus 9.81 and distance is 5 meters. So you would go ahead and you would calculate the speed. Okay. The second time is also pretty easy. Show that the time taken for the ball to reach the ground is 0.47 seconds. So you have the initial speed, you have the final speed, you just calculated it. You have the distance and you have the acceleration. So,
I
you could literally,
anything
yeah,
you can.
any equation is going to end up working over here. Okay, hold on, just give me a second. I want to find the equation for the formula of questions for your projectile motion. One second. Where's the projectile motion? Okay,
So
here we go. So this, yeah, this is a question that's related to your projectile motion, right? So first of all, you need to identify what type of a projectile are we dealing with over here.
so this is a it looks like a horizontal
Yeah,
projectile.
yeah, it is. Because it's not going up, it's directly, falling towards the ground. So this is a
Yeah.
horizontal projectile. Okay, so a ball is thrown horizontally from the top of a building as shown. The ball is thrown with a horizontal speed of 8.2 meters per second. The side of the building is vertical. At point P on the path of the ball is distance x from the building and is moving at an angle of 60 degrees to the horizontal. Air resistance is negligible. For the ball at point P, show that the vertical component of its velocity is 14.2 meters per second.
Or the vertical component of its velocity is this.
4.2, yeah, 14.2 meters per second. For the point P, at this particular point P, you have to show that the vertical component is going to be 14.2 meters per second.
Okay, so the we know that the initial vertical velocity is zero,
At
and
the
the
start, yeah.
yeah, and the acceleration is 9.81. So can we use like wait, so okay, we know v and we know u. And
Mm-hmm.
we don't know, we need to find, and we need to show that v is equal to, so we basically need to find the
Yeah.
time, right? Okay, so do we need to
This
use
is yeah.
trigonometry for this or
What do you
no?
think?
I
So let's okay, fine. Let's go first our data, right? So we know that our initial vertical speed is 0. We know our initial horizontal speed is 8.2 meters per second. Okay. We know
Mm,
our acceleration is 9.81, and we know what else do we know? We don't have the time. We don't have our vertical distance. We don't have that. Uh, we
the
don't have our
horizontal.
horizontal distance either.
Right. Okay.
So for the
Good.
kinematic equations, yeah, you need to have, you don't have enough data to apply the kinematic equation,
Right. Okay.
right?
So we need to find the resultant first, or is that completely irrelevant? I'm just asking.
Uh, you are on the right track. You don't need to find the resultant. You can
Okay.
just, but you are on the right track.
Okay. Okay. So we need to find we need to prove that the final velocity is equal to like 14, right? 14 point
Yeah,
something.
yeah.
Okay. And we
For
know
the
the,
vertical, yeah, for this. The vertical component is 14.
okay. So okay. Hmm.
You are on the right track. You have to use trigonometric ratios. Okay.
Oh,
So
we
this is
okay.
how
I was thinking that we didn't now. So I was like, where do I continue? Oh, okay.
you have to apply trigonometric ratios. You're on the right track. You don't need to know the resultant. To apply trigonometric ratios, you need to know an angle and you need to know one side. That's it, right? That's all you need to know. Do we know one side? Do we at least know one side?
No.
Okay. Tell me, what happens to the horizontal component of the velocity?
The horizontal component of the velocity,
Yeah.
it's it's constant.
What happens to it in a horizontal projectile?
The velocity, it remains
Yeah.
constant, right?
It
So
remains constant. Yeah. So it will remain the same, right?
yeah.
So if our initial horizontal is 8.2, then at point P, it will still be 8.2.
Okay,
So
right. Yeah.
technically, you know the horizontal component. You know
Oh,
your
okay,
angle. Yes. So you
oh,
can apply a trigonometric ratio and find out the vertical side.
okay. Oh, okay, because okay, now I get it.
Yeah, because you already know the horizontal part, because horizontal part will not change. So that you already know one component. So you have your angle, you have your component, you just need to apply your trigonometric ratio.
Oh, okay. So wait, tan 60 degrees equals
Yeah,
like 6 upon 8.2, right? So
yeah,
it,
exactly.
oh, okay. I thought you could only do that with distance. I didn't know you could use that like
No,
with,
no, you could use that. Yeah, you could use that with anything. It's because it's vectors. Wherever you have vectors, you can make a triangle and do trigonometric ratios.
oh, okay. So I think, yeah, the answer is coming to 14.2.
Good job. So that is how you're going to get the answer for this part. So that is what I meant. Like they'll make you solve for different components. Okay. So
Yeah.
now they're saying, now that you've done this, the second part is easy. Determine the vertical distance through which the ball has fallen.
Okay, right. So now we know this thing also. The
Yeah. Now we know the final component, final velocity as well. We know the final velocity. Yeah.
Yeah, we know the final velocity as well, and we know the initial velocity, and we know the acceleration. So I
Mhm.
guess we can do v square minus u square equals 2as,
Yeah. Good.
and we find the vertical distance,
Exactly. Good job.
like
So you
14.
would go. Yeah.
Yeah,
So just okay, go ahead and do that and let me know what answer you're getting because you'll need
yeah.
it for the
I'll just tell you the answer I'm getting. So, oops, sorry, 1 second. Oh my God. Okay, yeah. Sorry, 1 second.
Yeah, no problem. Take your time. It's no hurry at all.
Okay. Okay, so you square the v square and u square is equal to 0. Then I'm getting like the vertical distance as 10.3
Yeah,
meters.
that's fine. That's fine. I'm getting the same answer.
Okay.
Okay, so then that you know that you have to determine the horizontal distance x.
Okay. So we know the vertical distance. Could wait, we know the time. Do we know the
We
time?
don't know the time yet. If you want to find it, you can find it. We don't know it yet.
Oh, okay. But also, could we just solve it using the trigonometry again?
For the distance?
Or
No, not for the distance. The
okay,
angle
right.
is not given to you, right?
Okay, right. So first we could like find the time, I guess, because
Yeah. Also,
we
one more thing. Another reason you can't solve distance using trigonometry is because distance is a scalar quantity, not a vector quantity.
sorry.
Another reason you can't use vectors to solve for distance is because distance is a scalar quantity, not a vector quantity.
Ah,
So,
okay,
yeah,
right.
trigonometric ratios is for vectors.
Oh, okay, right. That makes sense. But like so when we like make those, I forgot what, like the parallelogram rule and stuff, you find
Yeah,
this
yeah.
using vectors, right?
That's displacement. Distance
Okay,
is a
that's
scalar.
displacement,
Yeah.
right? Okay, right.
Displacement is a vector quantity.
Yeah, okay, right. So I guess we could do v minus u upon a. So that would be, I think, 14.2 upon a. I am divided by 9.8, 1.
Hmm.
So that equals to our time. And then
Yeah,
the,
and then you can find your time and then you can find your distance. Yeah.
yeah. So that'll be ut plus half at square.
Hmm.
Um, wait, half 80. Okay, yeah. 9.81. And then divided by 2. Oh no, wait. Yeah, never mind. So it's 10.3, right? The distance.
Uh,
Oh wait.
distance. Yeah. Yeah, yeah. You
Okay,
know,
right.
there's a simple kinematic equation you can use.
Oh, the v
I mean,
square.
if the equation you're using, by the way, is completely correct. I'm not saying it's wrong. You
Yeah,
could.
no.
I'm just saying that you're using the more complicated one. There's a easier option for the kinematic equation that make your calculations easier.
Right. Oh, which one? Is it the v square?
V is equals to u plus 80, the first one. V is
Yeah.
equals to u plus 80. So u is 0, so it will become v is equals to 80. And then you just divide the velocity by
Oh,
9.8.
right. Okay, right. That makes sense.
I mean, it's just going to make your calculations faster. What you were doing was completely correct. You would get the answer, just it would take you probably a bit
Yeah,
longer.
it takes longer. Yeah, makes sense. Oh, hello.
Yeah.
Yeah, so we did the question, right?
Yeah. So you got the time, and then once you have the time, you just get the horizontal distance.
Yeah.
Okay. Okay, let's take a look at this question. This is again a projectile motion, only it's a bit the other way around. Instead of throwing it from the wall, you're sort of throwing it from the ground to the
So
wall.
this is
So
vertical.
yeah, this is vertical, exactly, vertical projectile, but like half of it. You're not worrying about what happens when it falls back on the ground.
Okay, right.
So the initial velocity of the ball, instead of it going like like this and then coming back down, they've only bothered to give you like half of it in the question.
Yeah.
Okay, so initial velocity of the ball is 12.4 at an angle of 36 to the horizontal. The ball just passes over the ball of height h. The ball reaches the wall 0.1 seconds after it has been thrown. Assuming air resistance is negligible, calculate the horizontal distance p from the wall. So you have to tell me what is the horizontal distance.
From point P. Okay.
Yeah, to the wall.
Okay, right. So first I guess okay, once again. Assuming this thing, okay. So time equals to 0.17 seconds. Vertical velocity, I mean final velocity equals to 0 and initial velocity equals to 12.4, right? And okay, so yes, so first do we find the what do you call it? So this is only vertical velocity, but this is both, right? This has vertical and
Yeah.
horizontal velocity.
Yep. It has both.
Okay, right. Okay, so I guess first we find the, because we know one side and we know the angle, we can find the vertical
Mm-hmm.
velocity. So
Uh,
the
okay. Yeah.
oh, never mind. Would it be easier to find the horizontal? I'm not sure. I
Yeah.
just
I mean, yeah, for if you want to find the horizontal distance, you need to find the horizontal velocity. It has to
oh,
match.
okay, right,
But
right. Okay, because we know the time, and if we find okay, right.
yeah, I mean, you in either way, even if you were using any equation at all, for the horizontal distance, you need to use horizontal velocity in your calculations. You cannot use the vertical velocity. Just like that, for the vertical distance, you need to have the vertical velocity. It's like a necessary thing.
Right. Okay.
So
Okay. Now.
automatically you see horizontal distance, you're like, I need to get my hands on the horizontal velocity. So you automatically have the first step. Find a way of
Right.
getting horizontal velocity.
Okay. Okay. So now I've got my horizontal because it's 12.4 cos 36.
Yeah,
So
good job.
that's 10 meters per second, basically. I mean, if you round it off like two significant figures,
Yeah, yeah.
and then you just what do you say, multiply it by the time.
Exactly. Good job. Good
So
job.
yeah, into 0.17. So it's like 1.7 meters rounded to the two significant figures. I'm not sure how
Exactly.
much. Yeah. Okay.
Good job. That's perfectly correct. Okay. Now the next part is asking you for the vertical height. So now you have to find out the vertical height h.
The vertical height h. Okay. So can't we use trigonometry to find this, or
The
is
vertical,
that,
the height h.
yeah, because we
The
know
no,
that
because once
oh,
again you're dealing with distance, right? Distance is a scalar quantity,
right.
so you can't
Okay.
use vectors.
Oh, okay, but would it wait, I'm just asking because it like looks like a triangle, right?
It
Or no,
does, it does, it
but
does. But you No, I don't think trigonometry is going to work because once again, it looks like a triangle, but the 36 degrees that is given to you is the angle for the velocity. Even though it looks like a triangle over here, but that might not be applicable for your height. Also, the angle that's given to you is for the initial velocity. That angle is going to change as the ball is moving. So that is
right.
not, yeah, it's not a fixed angle that's always going to be there.
Okay, right. Yeah. Okay. So we need to find the vertical height now.
Mhm.
And I mean, yeah, sorry. And we know the initial velocity, final velocity, and time and acceleration. So
Yeah.
we do 2s equals v square minus u square, I guess.
Yeah, if you want to go ahead, you can use that one, whichever one you find easier.
Okay, so okay, wait, the initial velocity is basically, I mean, the final velocity is 0. So it's just um minus this. The initial velocity is 12.4, right?
No, not exactly.
Oh, okay.
So the 12.4 that's been given to you, that is
The
actually the
resultant, right?
resultant.
Okay, so we need to find the
Yeah,
vertical velocity.
exactly.
Okay.
Just like you found the horizontal component, now you need to find the vertical component. I'll give you a hint. Whenever they say initial velocity of this at an angle, so they're always talking about horizontal resultant velocity. If they ever give you horizontal or vertical velocity directly, then they use the words following speed, or I threw the ball at 12.4 vertically, or I threw the ball at 12.4 horizontally. So that word is going to give you an idea that this is them telling you horizontal or vertical component. But if they ever say that this is the speed at this angle, then they're talking about the resultant one.
Okay, right. That makes a lot of sense. Okay. Okay, so I think the answer is because it's a wait, it's a this horizontal distance. Oh, wait, never mind. Now this is a vertical distance, right? I
Hmm.
got 0.7 meters.
Point 7.
No, 2.7.
2.7. Okay, hold on. So what you're gonna do is you're gonna go ahead and you are going to do 12.4, and you will do sine 36 because
Yeah,
you
30. Yeah, to find the
you
vertical.
need to get the vertical component. So the vertical component I'm getting is 7.29.
Yeah.
After that, you can go ahead and use v is equals to u square plus 2as. I think I know where you're going wrong. Your v square is 0. Your u square is 7.29, and 2, the acceleration will be negative 8.1. You need to be careful about your signs for acceleration because you're throwing the ball upwards. When you're throwing the ball upwards, you're going against gravity. So the acceleration will be negative 8.1. When it's coming back down, then it's going to be positive 9.81.
Ah, okay, right. Okay.
If you take negative a 9.81, you will see you'll probably get a different answer.
Okay, right. Okay. Maybe I'll try it. Should I try it again?
Yeah, go on. Just try and let me know if you're what answer you're getting.
Right. Okay. Oh, because I think I did it like this, like v square minus u square upon 2a equals to s, but I don't know if that's correct.
We Yeah, that's fine. That's fine, but your answer is probably coming incorrect because you're not taking negative 9.81.
Okay.
Just try it with the negative, like with the same what you're doing. You just rearrange the equation and you rearrange it completely fine. But just try it with negative 9.81 and let me see if you're getting the same answer as what I'm getting.
Okay, right. And negative this, right? Yeah,
Mhm.
I'm still getting the same answer.
You're getting 1.1.
No, I'm still getting 2.7 if I'm using
Okay.
negative 9, like 9.8.
You said you're using v square minus u square divided by 2a. This is what you're doing, right?
Is
Okay.
that like incorrect? Oh, mhm.
Z square, 0 square minus, and then you go ahead and you do, 1 second, 7.29 square. You get 53.1, right?
Yeah.
And this will be minus 9.81. So divided by 2, and then it's divided by 9.81. Hold on, just give me 1 second. Okay, let me just take a look at it, because when you are using the formula S is equals to UT plus half AT square, you're getting a different answer. When you're
Oh,
using S, yeah, when you're using S is equals to UT plus half AT square, you're getting a different answer. When you're using V square is equals to U square plus 2AS, you're getting a different answer. And I feel like you'd probably get the same answer if you ended up dividing this by 2. And the reason we want to divide it by 2, because if you remember, when we are finding our distance, right? I remember I told you, even when we're dealing with time, we would always, if you want to find out the time for the total journey, you always have to multiply it by 2. Remember? Because the journey we are looking at is from here to here. We are not looking at the entire journey. Okay? So let me just take a look at it. I'll look into it. I'll because I'm getting when you use the other equation, you're getting a different answer, and when you're using this equation, you're getting a different answer. So I'll look into this.
okay. Yeah.
I'll see why I'm getting a different answer using this equation, and why the other one is giving us a different one.
Like, what does the answer key say by any chance? What if it's something that we both don't know?
Hold on. Oh, give me 1 second. I'll open up the answer key. I don't have it open. Hold on. The answer key also says 1.1. They've also used UT plus
Oh,
half AT
okay.
square. Yeah, they've also
Then
used the
maybe it's
same
some
formula, and they're,
calculation mistake.
yeah, sorry.
No, I was saying that maybe it's like some calculation mistake on our
No, no,
part.
no. I'll look into it. There must be a reason. Otherwise, we should get the same answer from both the formulas.
Oh, okay.
Yeah. They have also used S is equals to UT plus half AT square, but I'll look into it. You should always get the same answer from both the formulas.
Oh, okay. Okay.
Okay, so let's take a look at this question. A ball is thrown against a vertical wall. The path of the ball is as shown. So this is again, you're dealing with the vertical motion. The ball is
Yeah.
thrown from S with an initial velocity of 15 meters per second at 60 degrees to the horizontal. The first part is horizontal component and vertical component. So let's just quickly go ahead and calculate what is the horizontal component and what is the vertical component.
Okay, yeah. So wait, 15. And it's to 60 degrees, right?
Mm-hmm.
So the vertical component is just 15 cos 60, right?
Yeah,
And
exactly.
15 cos 60. So that's 7.5 meters per second. So sorry,
Correct.
this is horizontal. This is horizontal, sorry.
And the vertical
Uh,
would be
it'll be 15 sine 60. So just that would be like that would be 12.99. So 12 point
round
and
that off. Good
yeah.
job. Okay. The horizontal distance from S to the wall is 9.95 meters. The ball hits the wall at P with a velocity that is at right angles to the wall. The ball rebounds at point F, that is 6.15 meters from the wall. Use your answers in A to calculate the vertical height gained by the ball as it travels from S to P. So you
From F.
have this ball from S to P. From S to
Yeah.
P, how much height is it going to end up gaining?
Okay. So basically the vertical distance.
Mm-hmm. Exactly.
Oh, wait, could you just see the other, like the values that they had given? I didn't write them down.
Mm-hmm. No, no, here you go. Go ahead.
Right. Okay, so horizontal distance equals
This is
9.
written over this 9.95 and the 6.15. This is written over here in the diagram. The horizontal distance is given over here.
Okay,
Just
right.
bear with me. just in case, you don't need to learn the values. It's written over here. But go ahead and read the question just in case for your own understanding. So you know what's being asked.
Okay. The horizontal distance from S to the wall is 9 point. Okay, yeah, sorry. The ball hits the wall P at P with a velocity that is at right angles to the wall. The ball rebounds to a point F that is 6.15. Okay. So what do you say? Final velocity is also equal to 0 because it's at 90 degrees to the this thing, I guess.
Mm-hmm.
And we need to find the vertical height gained. So and we know the
Yeah.
acceleration, and we know the acceleration
Yeah.
velocity, this
Yeah.
u. We can do use v square minus u square equals 2as to find the
Yeah.
vertical height.
Definitely. Yeah. Go ahead. Just do that and let me know what answer you're getting.
Okay, so okay, if I use that, I guess I'm getting 0 minus 13, I guess 12 point divided by 2 into 9.81. Okay, so I got my answer. I'm or minus 9.81. I got my answer is 8.6 meters.
8.6 meters. Yeah, that's correct. I'm getting the same one. Okay, so now that we have our vertical height, we have to show that the time taken for the ball to travel from S to P is 1.33 seconds. So the time taken to go from S to P is 1.33 seconds. So that's like a really simple formula.
Oh, sorry, what? What was the
I'll
question?
just no, I'll scroll down. I'll scroll down here. You can take a look at the second part. This is a pretty simple one. That's why it's like only one mark.
Okay, right. So it's just what do you call it? The distance divided by, oh no, never mind. Do you do 8.6 divided by the this thingy?
You know, you have your vertical height, right? You have
Yes,
your vertical
that's what I
height,
have
you have
to.
your vertical speed, you have your vertical acceleration. So you just need to find out the time.
Oh, okay, right. So it's S equals to UT plus half AT square, I guess.
Yeah, you could use that. You could
Or
use that, but you would end up with a quadratic equation that you would have to solve.
oh, okay. So wait, okay. So
There's a
we just
simpler
get,
kind. There's a
oh,
simpler
right.
equation.
U plus AT equals.
Yeah, exactly. Just go ahead and use that. So you already know that your v is 0, so you only have to think about the u.
Yeah. Okay, so that's the point. And then you, what do you call it? Divided by this 9.81.
Exactly. You get the time.
Yeah, it's 1.3 seconds, I think.
Exactly. Now, the final part is show that the velocity of the ball immediately after rebounding from the ball is about 4.6 meters per second. So they're saying that at this point, right? At this point where the ball has rebounded, so we have to show that the speed is 4.6 meters per second.
Okay, so okay, so the first the in this the initial velocity I guess is 0 because yeah. And then the distance is 6.1, and for this it's basically like horizontal propagation we have to use,
Yeah,
right?
yeah,
So
exactly.
we know the horizontal distance, and we know the horizontal I guess horizontal speed is 0,
Mm-hmm.
right? Oh
The
wait,
horizontal speed is not 0.
wait, sorry, right, the resultant speed is 0, right? Or the, yeah, the result,
Mm,
because isn't it like it's like the derivative is 0 if it's like at 90 degrees or something. Oh, never mind. Okay.
The ball hits the ball at P with a velocity that is at right angles to the ball. So basically, it's like this, like the velocity is going straight
Okay, so okay.
initially.
Oh, so it's like 15 meters per second, I guess. If because like all of it's because the velocity remains constant, I guess.
No. So
Oh
what
no,
is happening is the reason your
guess it
velocity
again,
is
right?
not, yeah, the reason your velocity, okay, so I'll tell you what is happening. They have done something a bit tricky over here. First of all, from here to here, you are dealing with a vertical projectile motion, right? After the ball has hit the wall, after the ball has rebounded, it turns into a horizontal projectile motion. Do you see what is happening? Initially, you were having a vertical motion. Now you have a horizontal motion because it's like something is falling off a cliff. You are now have a horizontal motion. That is why they said that the at P, the ball rebounds with velocity at 90 degrees. So the velocity is going completely straight like this. So that is your horizontal velocity, right? So
Yeah.
when we are talking about the velocity we have at the start, that will not carry through. The reason that will not carry through is because when you're rebounding, you are losing energy. When you are rebounding, there is a change in momentum taking place, right? When there's a change in momentum taking place, you are losing some kinetic energy. So the speed of the ball is going to change. So that is what they've asked. They've said, show that the speed of the ball after rebounding is 4.6. That is what you're going to have to show. So forget the first part of the motion, right? If
Yeah.
I had just given you this much and I had said, can you go ahead and show me what the initial velocity is? What would you have done? If this was literally the entire motion, there was like nothing else that I had given you in the question. This was a cliff, the ball was falling from there. So what you would have done is you would have said, okay, horizontal velocity I have to find out, right? Because at the start, vertical velocity is 0, remember?
Yeah.
In
Yeah.
horizontal motion, vertical velocity is 0. So if you can find horizontal velocity, that would be the velocity of the ball. So you have to find this horizontal velocity. The distance is 6.15. The time, which you have just calculated in the previous question, is
Oh,
1.3.
oh wait, what?
Yeah.
We did? Never mind.
Yeah. Just like over here, remember? You just solved it. Show that the time taken for the ball to travel from S to P is 1.33 seconds.
Oh, okay, right. Okay. Okay, so
Yeah. So the time
we
for the
just
journey
divide
is going to remain the
by
same. The
right?
time is not going to. Yeah, exactly. So yep. You just do you do speed is equals to distance upon time, 6.15 divided by 1.3, and that would be your answer.
Okay, right. Okay, so it's like 4.64, I guess.
Yeah. Yeah. That would be your answer. So you're getting your 4.6. That is what they asked you to show. They said that show us it's 4.6.
Right.
So
Oh,
that is how they tricked you up. They give you initial half of the question was in vertical motion, but after vertical motion, when it rebounded and started to go back, it shifted to a horizontal projectile. So the rules that you're applying would change.
right. Okay.
Okay. Okay. So I think let's just stop it over here for today.
Yes. Okay.
So yeah, I think in the next class, let's just go ahead and continue with questions on this particular topic, like get some more practice in, right?
Yeah. Right. Okay.
Okay.